In the last module, we have seen how biologists can make use of restriction enzymes to create different sizes of restriction fragments. They can use the restriction enzymes and create either complete digestion or partial digestion. And after creating different fragments, they can calculate the size of these fragments by making use of a technique known as gel electrophoresis. In this module, we will see how we can calculate the size of different fragments by using mathematics and algorithms. To formulate the restriction mapping problem, we will introduce some notation. A multiset is a set that allows duplicate elements. For example, this set 2, 2, 2, 3, 3, 4, 5 is a multi-set element. That is a multiset of 2 and 3, in which 2 and 3 is repeating more than 1. So if we assume that x1 is equal to 0, x2 and it will go up to xn, then it is a set of n points on a line segment in an increasing order. Then delta x denotes the multiset of all n choose 2 pairwise distances between points in X. So this n choose 2 means that the number of distinct subsets of K, if we consider it like n choose K, then it is a number of distinct subset of K elements taken from a larger set of n elements, and is given by the expression n factorial divided by n minus k factorial multiplied by k factorial. In particular, n by 2 is n minus 1 divided by 2. So we can calculate this n minus 1 by 2. For example, we have this n factorial, n by k factorial, k factorial. Then we can calculate n factorial n minus 2, because here the value of k is 2, and then 2 factorial, and that is n minus 1 divided by n minus 2 factorial by 2 factorial, and we can cross multiply with 0, n factorial. N minus 2 will be cancelled by n minus 2 factorial, and we will left with n minus 1 divided by 2 factorial. So we can also formulate this one. So if we assume that we have a set of these elements and we plot it on a line segment starting from 0, 2, 4, 7 and 10, we can calculate all the possible subsets of this set. For example, then the answer will be delta x will be 2, 2, 3, 3, 4, 5, 6, 7, 8 and 10. And we can also calculate like this if we assume 0 as x1, 2 as x2, x3, x4 and x5. We can then calculate the subset of this set, that will come out to be total of 10 elements. And we can calculate like this: x2 minus x1, x3 minus x1, x4 minus x1, x5 minus x1, x3 minus x2, x4 minus x2, x5 minus x2, x4 minus x3, x5 minus x3 and x5 minus x4. If we calculate all these values, then it will come out to be 2, 2, 3, 3, 4, 5, 6, 7, 8 and 10. We can also draw a table to calculate the same values. For example, we have a set of 5 elements 0, 2, 4, 7 and 10. We can write it in this direction, x-axis and y-axis. same 0, 2, 4, 7 and 10, and then we will minus this one from each other. 0 minus 0 is equal to 0, that's why nothing is written here. 2 minus 2, 2. 4 minus 2 is 2. 4 minus 4 is 0. 7 minus 7 is 0. 10 minus 10 is 0. So we can calculate by subtracting these values from these values one by one, and we come up with these same numbers. We can see that 2, 2, we take this one first in diagonal position, and we will come up with the same numbers. 2, 2, 3, 3, then 4, 5, 6, then 7, 8 and 10. So we can very easily calculate all the possible fragments that will be created when we try to find all of these fragments by using this table.